Hello everyone, welcome back. So this time we're talking about wedges and frictional forces on flat belts. Okay, this is a fairly interesting and amazing topic. Let me get my pen out. So we're going to focus on the applications for a little bit longer than we might normally. Okay, so first off, why do we care? Well, one thing to think about is you see wedges everywhere. We use them for all sorts of things. Keeping that door from opening, use a wedge. Holding things in place, you see cars, they put wedges underneath the wheels to keep it from rolling. Same thing with airplanes. It might seem pretty amazing considering like an airplane, like, well, it's got those engines. Why is it so easy to keep it in place if there's a simple wedge? Reason for that is because those engines are great. However, they're not enough to get off the ground if it's not able to move. And also the motors that are on the wheels are actually very, very weak, so you can't escape them. I mean, if they turn on the engines full blast, they probably could just blow right over them, but that would be a horrible, horrible start to a flight. Okay, so you see this, and you see that this tiny wedge is able to hold this in place. In fact, if we were to hit this wedge, we could probably begin to move this and roll this big steel thing over. But one question you might be asking yourself is, well, how much force do I need to apply to move this up? Or how much force do I need to apply to pull this out? How do you figure that out? It isn't the easiest problem, but it's not terribly hard either. And just as a note, you're going to have to always wonder, well, is friction going this way? Or is it going this way? You're going to have to figure that out by thinking about what direction everything is moving. Okay? Which direction is motion impending? That will help you. And of course, I drew right over that. Give me a second. There you go. Second thing you ask yourself is, if there's nothing applied to this wedge, will it stay in place? This is called self-locking. It's where the friction force is enough to hold it from moving. Or maybe just over time it's going to begin to move and then pop out and this thing goes rolling down a hill and bad things happen. Another place we see friction is not just in wedges, but in belts. These belts right here. You might see these if you open up your car's engine. You might see one of these connecting your alternator and your engine and various other parts of your vehicle. See, one nice little flat belt. What's interesting about those belts is some of them will have little teeth in them to help it hold on. Usually it's rubber belts, so these aren't really very hard teeth. But not always. In some situations, it is just a flat belt. And the only thing holding it in place is friction. So, how do you know if the belts are going to function properly? Because, like, let's be honest here. If this is a flat belt, no teeth, and let's just say that I held this wheel right here still. I don't let it move. Well, this thing could still move, and it might just let the belt slip around, or it might be that the engine's not strong enough, and it will just get stuck. So, how do you tell what's going to happen? How do you tell if that belt's going to break? Well, we're going to figure that out. Okay. Right here we have a band break. And then once again, it's really, really helpful because we need to know how to do this to understand the forces acting on the band, which in this case acts like a belt. This is the band right here. Can't really see it for most of it. So how can you determine the tension of the cable pulling on the band? And second thing is, how are the belt tension, this applied force P, and the torque M related? Well, how are they? So all of that is something we're going to be talking about in this section. It will involve free body diagrams. It will involve your equilibrium equations, just like always. So get ready for that. Get ready for it. I'm looking forward to seeing it. So stop here, and next time we'll talk about wedges and belts and jump into some problems after that. Hope this helps you. I'll see you all later. Bye-bye.